Alrighty, so I think, well, I'm ready to get started if everyone else is. I guess let's start. So basically the topics I'm going to cover today are joins. We're going to talk about outer joins, which left, right, full outer, inner joins, natural joins, comma joins, and cross joins. I actually didn't talk too much about subqueries, so I didn't really get into the dependent subquery and the derived table, like what's the difference. I can. And I try to keep it to 2 hours, which is kind of ridiculous. And I'm tired tonight, so we're gonna go over a little bit about changing a subquery to a join. I have one kind of example, and it's more the way of like how to think about things. In the example that we're gonna use, it's basically the example is a 6-week intensive course. There's homework every Friday. Each assignment is 6% of your grade. The lowest grade is dropped, which is 30%, so that's 30% of your grade total. Same thing, weekly tests every Monday. Same grading structure as your homework. So your midterm is Wednesday 120, which is 15% of the grade. The final exam is Friday 212, which is 25% of your grade.
I'm taking that class.
Yeah, it's a pretty bad course. It actually even has homework the first Friday. January 1st is a Friday, and there's homework due. So it's really just a bad system. And the final exam is like in the 6th week. So it's really 6 weeks plus 1 day. So there's going to be a few tables, 4 that we're using, but 3 real ones that we're going to be playing with. There's a work table, and basically that's the homework, the tests, the whatever with the grades. So that has a work ID, a work name, like homework 1, test 3, final exam, when it was given, so an exam when it was given on, and homework when it was due on, and then percent of grade, which is a tiny int, and then the primary key is going to be the work ID. So actually, and then I have it DB because there's going to be some foreign keys later on. So I can show you this, but basically here's your your percent of grade, and homework 1 is on the 1st, and test 1 is on the 4th, and here we've got the midterm is work ID 7, and the final is that. There you go. Now obviously if you added this all up, it would come to 112% because you have to drop 1 grade, right? So if I do, here I could do select star from work. And if I do select sum of percent of grade from work, it's 112%. So there's a student table for the students. Because this is such a crazy course, there's actually only 4 students. So you have a student ID, which is an auto increment primary key, the name and an email address, and then like I said, primary key, and again it's going to be DB. So you've got me, I'm student number 1. This is at FU University. You've got Giuseppe Maxia, Colin Charles, and Ronald Bradford. So then we have the student work table, which joins them together. It's basically who got what grades on what assignments. So you have a student ID, which is a foreign key. Oops, here we go, a foreign key to the student table. Similarly, we have a work ID, that's the foreign key to the work table. And then we have the grade number, the grade letter, is it for the grade or not, so the lowest grade is dropped, so everybody will have a few of these. And then again, indexes and the foreign keys. And so I inserted some things into student work. So basically I had an 88 for each homework test except for homework 6, which I got a 72 on because it was the last week and I wanted to study for the final. I got an 88 in the midterm, I got a 90 on the final, and I actually didn't take test 3 because I was lazy. Similarly, Giuseppe got he completed all of his assignments, and so for instance, if you look here, you'll be at 1, 2, 3, 4, 5, I'm missing number 6, so it's 7, I'm missing 8, 9, 10, 11, 12, 13, 14. Giuseppe had all 14, you can actually look and see if you want to count how many. Colin is busy planning the 2010 user conference and didn't actually complete any homework assignments, and as a result didn't do well on the test. So he's got a bunch of these here. And then Ronald knew his stuff but got busy as the course went on, so he starts off with hundreds and 95, 90, 85, 80, 75, and then got an 83 on the final. So that we have all of our information just set up. We also have a global grade num letter table, which just has the grade number and then the grade letter. Probably don't need this for this example. I was going to deal with joins and updating, and how do you update the table. So for right now, if we do something like select star from student work limit 5, you'll see that everybody's grade letter is null. So we can ignore that. But if you do something like select star from grade num letter limit 5, you'll see that for everything from 0 to basically 101, you have the number and then the letter. So we probably don't need this table, is what I was basically trying to convey. But we can play with it later once we get into the examples. So I've drawn here a Venn diagram. We're probably all very familiar with this, but I wanted to illustrate with pictures, starting to think in sets, because with SQL as a theoretical language, but also with MySQL, you're going to get better optimized queries if you think in terms of sets as opposed to, what's the path I take to get this data. So we have here two tables. Table 1 is over here on the left side. Table 2 is over here on the right side. They have different columns in there, and this overlap is basically the entire row where T2.column1 is the same as T1.column2. Now there may be other columns, like column 1 might be in there. This is just basically kind of a way to understand, okay, what matches each other. For instance, there are some fields in the student table that don't join with the same tables in the student work table, right? The student ID table, the student ID field is common to both, but there's a lot of stuff that's not common to both. And if you were going to join the tables, you would join where T1 T1, so like student.student ID equals student work.student ID. But there's still like the name over here, and over here there's the grade num or something. So that being said, MySQL joins. So when you're using a join, you can have a join clause. It's optional, right? So you might do something like A join B on student A.student ID equals B.student ID, or you might say using student ID. So with on, you can actually put any kind of, you have to put the fields from both tables, but you can also say things like where, column 1 is less than 10. You don't actually have to use both of the tables that are in the join in there. With using, it's actually just a shorthand for columns with the same name to be able to say these are equal. So kind of like a natural join, which will just join the tables together based on the columns with the same name. But if you actually have two columns with the same name and only want to join them on the one column that has the same name, for example, actually one of the things that I was going to do is show you here. So in student work you have the grade num field and the grade letter field, and in grade num letter you have grade num and grade letter. But you wouldn't actually want to join them based on both fields, because they actually wouldn't join, because these are null and these actually have the grades. You would want to join them in the grade num field so that you actually can get the information. So one important thing about MySQL is that inner join, cross join, and the comma join all do the same thing. Starting with MySQL 5.0, the comma join is actually lower precedence than other joins. So the term cross and the term inner, it's just syntactic sugar. The comma is similar. However, if you have something like, select whatever from table 1, comma, table 2, take the on out because I have the where here, where table 1 column equals table 2 con. Inner join table 3 on this. So you have a comma join and then an inner join. What that's going to do is it's actually the inner join takes precedence. So it's going to do this join first, table 2 inner join table 3, and then join table 1. If you had two inner joins or two comma joins, the optimizer would just optimize to figure out whatever the right thing to do is. But if you mix comma joins and anything else, cross joins, regular joins, inner joins, you're probably not going to get the right what you expect. I mean, my gut instinct is a comma join is just kind of like, yeah, whatever, right? Whereas if you're specifying an inner join, you're saying, okay, join these together and I'm going to be, having some equality there, whereas the comma doesn't even necessarily say anything. You don't even have like I don't even know if you can have an on clause in a comma join. So a cross join is a Cartesian product. You get all combinations. So if you had a little league and you wanted every team to play every other team, you could generate a table like that. In this particular case, if we do this, select name, W name from student cross join work, what we're going to get is we're just going to get a listing for every name the work name. So it'll say, Shiri Cabral, homework 1, Shiri Cabral, test 1. Which actually becomes important later because, so there's 56 different things, because it's 14 people or 14 assignments times 4 people. So select 14 times 4, if I'm doing my math right, 56. So it's actually 56. So one of the things is I actually didn't submit, was it test 3 or homework 3? So if I do select star from, or actually if I select work ID from student work, where student ID equals 1, you can see I'm missing number 6. So select star from work, number 6 is actually test 3. So if I wanted the grade for test 3, if I used, I would have to kind of put a cross join in there so that I could actually get this with a null setting. Because I don't have an actual entry in the row for test 3. If I do select star from student work where student ID equals 1 and work ID equals 6, there's nothing. So if I actually want to find out that grade, I'm going to actually need a little more information than, I can't just do a regular inner join because there's no row to join. Usually you don't want a Cartesian product. There are very few cases in which you do. It's usually very explicit, something like this, where you actually want, one row for every student, give a row for every assignment.
As data gets larger, it creates a geometrically larger data set too.
Yes.
So if you have 10 records in one table and 10 records in the other, you end up with 100. If you have 1,000 records in each table, then you end up with 1,000,000 records.
Right.
Sherry, looking at your Venn diagrams, so the Cartesian product, is it going to be like aggregation of two independent circles completely?
Yeah, you could say it's actually more than that. It's multiplied. So there isn't really a good way to show it because it's not just addition and subtraction. It's actually just multiplication. So if I were to show it, I would probably show like the 2 circles overlapping, and then the result set is like that much bigger because it's it's that much. That's why I don't actually have a diagram for that, because it's kind of hard to show in that kind of a Venn diagram in kind of a way. However, the inner join, for example, this is the inner join is actually what this overlap is. So if you use an inner join, you're not going to get things, if there's something in table 1 that doesn't match anything in table 2, you're not going to get it. Similarly, if there's something in table 2 that doesn't match table 1, you're not going to get that either. So when we do something like select star from student work where student ID is 1 and work ID, well, we don't have a join there, right? If we do student work, inner join student, let's say, and where name equals Shiri Cabral, then you end up getting 48 rows because I didn't, what did I not do? I didn't actually put a join clause here. So I actually got 1 row for each of the rows in student work. I actually got 1 row for a student where there's a bunch of null stuff for some things. So I actually want to inner join student on, or actually probably using student ID. So the difference between using and on is that with using, so now it's 12 rows because there was 2 things I didn't do, 6 and 8, whatever they were, I didn't hand them in. The difference between using this on and on is if I wanted to use on, I would have to say on student work dot student ID. I can alias the tables, but I have to specifically write out that this equals that, student dot student ID. And it's the same 12 rows. So obviously this is a lot longer than the using, but if I wanted to say, where something like this, let's say, and work ID equals 7, I could do that in the on clause. In this case, it doesn't particularly matter. That's something that I could put in the where clause or the join clause. It's not really a condition for the join. I like to keep the join conditions and the where conditions separate, because you could also do, you could do it this way and don't use a join clause at all and say where and where is it, student work.studentID equals student.studentID. And the optimizer actually will optimize this the same as either the using or the on, same thing. But I don't happen to like it because then you kind of have all of your tables in one place, but how they join with each other is mixed in with your filters, right? So how A relates to B is now mixed in with where student equals Shiri Cabral. And when you get a 7-page query, sometimes you want to know which is a join condition and which is just, okay, I want these or I don't want that as a filter.
Is there any difference in optimization depending on where you, like you have the work ID equals 7
Right.
inside the join condition?
In this case, no. If there are cases, there may be cases where, especially with outer joins, where you would want to put it in there, but that gets into complex things. Like I looked at it with different. I looked at the optimization with different things, and just for simple outer joins, it was fine. With simple inner joins, the same thing. But again, it might be. It depends on how you're thinking about it too. You know what I mean? Like my kind of feeling is, if I say that work ID equals 7 is a join condition, then if I were the optimizer, what I would say is, filter this stuff out before you join it. Which the optimizer doesn't think that way. The optimizer is just like, well, I need to filter this out and I need to join it, so when do I do it? When's the optimal time to do it? And it will just do the right thing. But that's kind of why I'm kind of, doing that is almost a procedural thing, and MySQL is declarative. You say what you want. Show me everything from this table, and this is how it relates to this other table, and show me where the name is Shiri Cabral. You're basically declaring what you want to get back. You don't care if it iterates through each one. You care obviously, because if you're doing a full table scan, that's not going to be very performant. But you're not telling it how to do it. That's why you have the optimizer. So it's actually very hard when you're moving from like a development mindset where even if you're not a procedural developer, if you're using object-oriented stuff, you're still making methods. You're still telling and programming how to do something. Okay, this isn't programming how. This is just saying, show me this, right? Genie of the lamp, I would like to see this result set. And if you can, it's not always, I don't even always think like that, but if you can get in the mindset to think like that, then it actually works really well. So if you've done any work with set theory and intersections and unions or whatever, SQL theory actually comes out of that stuff. So that's where you get into these, Venn diagrams and whatever. So hopefully we can kind of learn a new way of thinking, and that's kind of where I'm going with this particular session. And then, maybe next time we can get into more, complicated, how do I make my joins kind of really, really fly. So this is what an inner join looks like. It's basically when you want to get the overlap and you don't want anything that doesn't match to show up. So again, show only rows that matches on both sides. You can tell I was tired even this weekend when I wrote this. So this is where we might do something like, here I want the grade number and the grade letter from student work as S, inner join. So I'm aliasing the table, so student work is going to be called S. Inner join grade num letter as G, right? So and then I'm doing it on the grade number. I could have said using grade num, but I didn't. So I said this before, but cross and inner are semantic. So I actually did, we just did this where I had select this with inner join, but I could have said cross join. Gives you the same results. This is somewhat of a confusing thing. If you saw this, you would say, well, this person wrote cross join, but they don't mean cross join, right? They wrote cross join, but then they had this on clause. They didn't really mean a Cartesian product. They really meant like an inner join. So why did they write this? So actually, if you want proof of how that works.
Because that's semantically a cross join followed by a select.
I'm sorry?
Semantically, it's equivalent to cross join followed by a select.
No, semantically.
Yeah.
Semantically, if I say. If I do this query, if I have this, if this word is cross or this word is inner, it does the same thing. It's just a word to MySQL. MySQL doesn't actually care what that word is,
No,
if it's inner or cross.
But what semantically happens is if you do a cross join and then you do selection on the columns being equal, that's exactly what you're getting from the where clause, whether it's
The optimizer actually optimizes that out.
that, yeah.
Because the MySQL optimizer will say, hey, it doesn't just dumbly say, okay, they said cross, so therefore it's a Cartesian product. Because what he was saying is, if the optimizers took this and said, okay, well, we've got a cross join, so what I'm going to do is I'm going to do a Cartesian product of student work and grade num letter, and grade num the letter has like 101 different things, and this has 56 different things, so I'm going to do 156 rows, and then filter things out with this like on clause, or if you used a where clause. That's not how the optimizer works. It sees, oh, I've got this on clause, therefore I'm not going to worry about it. Same thing here, you've got the words inner join, but they act as a cross join. And this is actually, this is more of a big deal that you see more often, where here I just innocently forgot a where clause or an on clause, my join clause, and I, get all 56 rows of, what happens when you do your cross join, your 4 times 14 here. It's the same as doing cross join. So the moral of the story, or the point I'm trying to make, is that you can be really careful about writing inner join and cross join, but it means nothing. You still have to put that stuff in there. But if you put, and you don't even need either. You can just use the word join. So whether you use inner join, if I use inner join here, or cross join here, or just join, the optimizer does the same thing, the results are the same, everything's the same. So, if you wanted to copy and paste these examples, you could do them, or you can just believe me. So we talked about the join clause. You have on or using. You can specify it in the where clause, and it's the same results. And I say that all because my best practices are, don't use a comma to join. Just don't do it. Because there's unexpected behaviors, especially if you have other joins in the query, just don't use comma joins. I always like to never actually use join. Always use inner join or cross join. Okay, now you still have to write your query correctly. You still have to put, an on clause or where clause to get the right result. But whoever looks at your query and goes, what did they mean to do here? If you see this query down here, right, you have no idea what I meant to do. Did I mean to do a cross join? I don't know. That's what I'm doing, but was that what I intended? Now, obviously, you could probably look at these two tables and say, okay, student join work. Well, maybe does it make sense to get a Cartesian product, to get one of each of the rows in work for each student? And you can say, okay, yes, it does. But again, when you have a 7-page query and you're like, why are they doing a Cartesian product? 99% of the time, they are doing it because they didn't realize they were doing it. They were doing it because they put all the tables in the join and then started putting all the where clauses in instead of using join clauses, and forgot one. So that's my best practices. You don't have to do this. It's more words, and people are like, well, doesn't the query get longer and then you're sending more information over the wire? And I'm like, well, the word inner or the word cross is not that much of a big deal. And I like to use a join clause instead of a where clause. And that's just for the things that you're joining on, just for the conditions that you're joining on. Obviously, you don't want to get rid of your where clause if you have actual where clause things. But it's just, again, more clear to whoever's debugging when things go wrong, what's actually filtered out and what's actually joining.
Does that ever have any effect on what the optimizer produces, where you put that?
Does it ever have any effect of where you put it on what the optimizer produces? Sometimes, but I haven't found any big patterns to it. It's usually, again, when you get these complex, 8-table joins, you're like, oh, if I do it this way, then it's fine. I mean, usually the only way I find that is because I, Google search for it and I go debugging or find a MySQL bug somewhere, and somebody's like, oh, if I do it this way, then I'm fine. So getting the letter grades, we actually did this already. We updated it, but I'm putting this in here as the table. So you have student work as S is in here, grade num letter as G is in here. So grade num letter has G grade num and grade num letter here. So this is not something that's being joined on. This is still the inner join scenario here you're joining on the grade num field, and here the student ID, work ID, grade num letter, for grade, they're not being used in the join. They may show up in the result from an inner join, but they're not what's being joined on. So an outer join, it shows all the rows that match on one side. So the inner join showed only the rows that matched on both sides. So for example, getting all the grades for test 3, here's one example where I actually use a cross join as well. So I start with select name, W name, grade num. So we're getting all of the grades, so we're getting the name, the work name, and grade num, although I guess we don't need to because we have where W name equals test 3 down there. But that's just, I like to be able to see it so that I can see everything says test 3. That's just my thing. So I have student cross-join work. We saw before that student cross-join work gets you that Cartesian product of every, one column for everything. And then I did a left outer join onto student work. So here I have this table, right? This intermediate table right here that I get from here is, rows of every assignment for every person, a theoretical thing. I don't have any information on whether or not they handed in or what grade they got. Once I do this left join, now with a left join, what I'm saying is take every row that I've gotten so far, so in this whole thing, even though this is 2 tables, right? Imagine, now again, this is not how MySQL necessarily will do it, but think of it as, okay, I've cross-joined these 2 together. Now, let me take every row that's this intermediate cross-join and do a left outer join to the student work table using student ID and work ID. Now, not every row will actually have a complement in student work. For example, Shiri in test 3 doesn't have anything. So let's see what we get here. We get 4 rows, because there's 1 row for every student, because we did that cross join. And you can see that for this test, my grade is null. But you still get my name. So this is really, really very important when you're doing things like reporting. You have something like sales per day, and you have 1 day that doesn't have sales. You want that day to show up with no sales, right? You might want 0, and in that case, you can actually use the coalesce function. Select name, and then here we'll use coalesce. So coalesce basically says use whatever the first field is, unless it's null. And if it's null, use the second field. So the second field here is 0. But I could actually say, use name or whatever. It doesn't matter. It doesn't have to be a number. It can be an expression. So I'll do that, and then you'll see that I got a 0 on that assignment instead of left outer join student work. Using that, and I'm going to want my where clause. Where's my where clause? There. So now you can see instead of null, I got a 0, which is really, really helpful. A lot of people say, I've got sales of states. I break down sales by state and by day, and Hawaii never gets any sales, but like Alaska gets sales on Monday, Tuesday, and Wednesday. But I want to see zeros in the column. That's what you're using your outer joins for.
Can't you take the word outer out of that and
You
it'll work
can.
the same?
That's on the next page. So you have left outer join and right outer join. They're very similar, and I'll show you a Venn diagram in a second. Outer is redundant, and in fact, just as in my best practices where I say always use cross join and inner, and always use the word cross or inner to kind of specify, almost make like self-documenting query. You don't need outer. If you say left join, there's no way to do a left inner join or right inner join. So there you can save yourself the typing because there's nothing that it could mean. Here's a left join, and I say this is a left join inclusive because this is basically saying, this is basically what we just did. We just had table 1, now again we had kind of an intermediate table, and then we joined it with table 2 on a column, but if it didn't exist in table 2, we still wanted to see it. So just because Shiri's test 3 didn't appear in table 2, we still wanted to see it. If we used an inner join, we wouldn't have seen it. And in fact, I can actually show you that if you use an inner join here, cross join work, if I just do an inner join, yeah, using that, where that, you only get 3 rows here. Because I did an inner join and I did an inner join using student ID, work ID. So it said, okay, I'm going to, there's no outer join here, it's some kind of inner join, right? Whether it's a cross join or whatever, it's giving me everything. And so I didn't get Shiri because she didn't have a row. That student ID didn't have an entry in the student work table. So that would be only this overlap. That's the inner join. The left join says, give me everything from the left-hand table and only give me stuff in the right-hand table if it matches. If it doesn't match, put null in there. Now, if there's a left join inclusive, you can guess there's a left join exclusive. Now, the difference is whether or not you have this overlap. So sometimes you want to say, show me everything in table 1 where there isn't a match in table 2. Right? So for instance, maybe I want to see a student that doesn't have anything, and maybe I want to see who didn't do test 3. So to see who didn't do test 3, I would do this this same thing here, except instead of this, let's see, left outer join using student ID, work ID. Now, using means that student ID from one side is going to be equal to student ID from the other side. I want them not to be equal, so I can't actually use using anymore. So this is one of those places where you might not use using. So now I have to say student ID equals student work dot student ID and work dot work ID equals student work dot work ID. And then where W name equals test 3, but I also want I can pick anything from table 1 is null, right? Anything from one of the tables is null. So if I want, whatever I want null to be is where I don't want the overlap, right? So here it's where T2, it's actually the right-hand table, where T2 column 1 is null, because that will take this away, take the overlap away. So here, here the table 2 is student work, right? Because the table 1 is this together, and then table 2 is actually student work. So I want to say where student work, let's say dot work ID is null, and then I only get Shiri Cabral. Because what this did was, and I coalesced it, but the grade num is null as well. It's showing me where student work.work ID is null. I could have put any of the fields from student work in there, in that where clause, because they're all null, because there's no matching record. So if you think about it before it takes away all the columns for the select, if you want to think about it in kind of a, this isn't actually how the optimizer works, but if you wanted to think of it like this, you could say, okay, well, I've got student cross-join work, so I've got all the columns from student, then I've got all the columns from work, then I've got all the columns from student work, and I'm going to filter where W name equals test 3, so I'm filtering those rows, and then I'm filtering where student work ID is null, and then I'm filtering the columns out. So I'm only showing name and W name. But I can actually show you, select name, W name, and then we can do something like student work.star. And you can see that name, W name, and then everything after that is null, because there was no matching row, so every single column there is null. So this is an exclusive left join. And I did that just because I realized when I was making the Venn diagram, my first instinct was, here's a left join. And then I realized that this is also a left join. This helps me when I'm trying to figure out, well, do I do a left join, or do I do an inner join, do I do a cross join? I think about it in the set. What do I want? And if I want either this or this, I might use a left join. Like a lot of people just think of one kind of left, okay, if I do this, then I need a left join. Well, that's not really the case, because what if you have an inclusive left join or an exclusive left join? And this is going to help actually when you optimize, trying to optimize away subqueries. Like a lot of times, the way that people try to write this query is they'll write the left join, the inclusive left join, and then they'll say where t1.call2 not in the inner join that's just this overlap. Which works. You're taking this and you're subtracting this. That's exactly right. You will get the right answer. It might take a while because basically MySQL may, depending on how it optimizes, it may run this overlap for every single row in this, in this left table. It may have to run that. So a full outer join doesn't actually exist in MySQL, but it can be simulated. So this is what a full outer join inclusive is. It's everything. Now, so is a Cartesian product, right? It's more than everything. But basically, an outer join is the results of a left join plus the results of a right join. Okay, so a left join is make sure that there's one row for everything in the left table. Similarly, a right join is make sure there's one row for every row in the right table. So, for example, one thing that you might want to do is something like, let's see, student left join. We already saw student left join student work, right? Or student cross join work. And then left join student work. But from here, maybe we want to right join it to grade num letter. And if we put in all of our join clauses, we might, why would you want to do this? I don't know, but this might be one way where you might use, like, say, both a right join and a left join. You're basically saying, give me this grade, give me, one row for every grade, and also give me one row for every, student cross join work. A full outer join, again, it's one of those things that doesn't have a lot of uses, but it's like a cross join. When you have a use, you know it. So the first instinct is, well, I can use a union, right? Just take a left join and then union a right join. The problem with that is that union will eliminate duplicates. So if you end up having a duplicate, even if it should be a duplicate, right? Maybe it's a duplicate because there's one row here that matches, that's the same as one row here, right? You don't want that duplicate to be taken out of, because the whole point is it's a left join plus a right join, but no filtering duplicates. Well, then you might say, well, what about union all? Well, then you might get extra duplicates. So the real way to do a full outer join is to basically, again, like we were saying, if you only have certain pieces, you can add and subtract them. So you say, do this left join where I get this piece, and then add in this exclusive join, right? So basically what we're saying is, take this piece, and then add this piece for the right join. Add like the mirror image, so it's that. So that you're getting this plus this section. Oops, that's not it at all. That's what happens when I use the keyboard for everything. So what we do is we do the left join, right? Select whatever from table 1, left join table 2. And then we do a union all, select from table 1, right join, and then where table1.col is null. So it's this exclusive join, and we're just adding it with the union all, and that shows you all the duplicates. But it shows you only the right duplicates, because you're already taking out any duplicates in that overlap area. You're only using that piece. So yeah, in the second query in the union, only rows that have no match in table 1 are taken. So you're basically saying, show me all of the things, the left join, the first part says, show me all of the things that are in the inclusive one plus the overlap, and then the second part says, show me all the things that are in the other one. You could also do an exclusive left join, an exclusive right join, and then the inner join. But that would be 3 unions, this is 2. If you really wanted to, you could, I leave it as an exercise to the reader, as they always say, to see like what's better in your environment. I would think that 2 joins would be better than the 3, but it probably depends on what indexes you have and all that kind of stuff. There's also an exclusive full outer join, which is this picture. Basically, it's the inverse of an inner join. Don't get me anything that matches. Only get me the things that don't match. Which, again, it's one of these things that you don't necessarily have a use for, And it's hard to see when you're writing a query that that's what you're doing. So if you actually sit and draw little circles and like, okay, here's this set and here's that set and what do I want? Oh, I want the things that don't overlap. Oh, that's a full outer join. Here's how it's done. Now I actually had, unfortunately, while I was looking up how to do full outer joins in MySQL, because MySQL doesn't have the syntax, every single resource I had shows like, here's how you do a full outer join. And I was like, well, I was already found the things where I'm talking about left outer joins, inclusive and exclusive. So I'm sure there's like an exclusive full outer join. And when I drew the picture, I'm like, well, duh, right? Here's the one thing I'm not showing, right? Because I have when I did my little pictures, because these are all with the GIMP. I made the pictures. I'm like, okay, well, I've got it when the whole thing's shaded. I've got it when nothing's shaded. I got it on the left. It's like this was the one picture I was missing. So I'm like, well, how do I do this? Can I do it? Do I have to do the inclusive full outer join and then subtract the inner join? That's one way to do it. Another way to do it is to get both exclusive outer joins.
And then union them together.
And then union them together, which is exactly what what I ended up figuring out. I don't know if this is the most optimal all the time, but it's very similar to the inclusive full outer join. You're just actually adding this other table 2 column 1 is null, and I've actually made it a little easier here where both of them are column 1. Before they were different, like one was column 1, one was column 2. While I was doing this, I thought it was a little easier to just make them both column 1. So basically, you have, the only difference between the inclusive and the exclusive is this one little where clause. So anyway, this is why this got a little long and why I'm not doing the more advanced thing, because I thought it was really important, even though probably all of you are like, yeah, I know what a join is, It helps to think of it this way in the declarative thing. So there's natural joins. We talked a little about it, but natural is actually a modifier, which I learned while doing this. I thought a natural join meant it was an inner join. That's not true. You can have a natural left join and a natural right join, or a natural join. The join clause if you use natural then you don't have a join clause. You don't use on. You don't have to put where ID 1 equals ID 2. You don't have to do that. In fact, if you try to use on or using, it'll give you an error. But it joins on all of the matching field names. It doesn't actually use any foreign keys. It just uses the matching names. So for example, when I first started doing these tables, I actually had the student table and the work table each had something with a name. So it was the work name, which is homework 1 or final exam. And I actually changed it to W name because when I was playing with natural joins, I had beat myself over the head because I'm like, why isn't it working? It wasn't working because it was doing a natural join on name, nothing matched. Because my name, you have Sherry and Ronald and Giuseppe and Colin, and none of those match homework 1, test 1, final exam, whatever. So it also works for left and right joins. So one of the biggest caveats I have for this is there's two. Well, for me, I think there's two schools of thought when you're talking about using things like select star or insert without naming your columns. Some people say never do that. Never use select star, always name the fields, because you don't want to necessarily be, one day you might add like a text field to it and you don't want to be retrieving the text field if you're not using it. And that's true. There are some cases in which you want select star because the application is literally going through all the data. So if you had that kind of a thing, it would be a pain to every time you added a column to have to then go to your code and add that column. Similar things with inserts is that, in general, usually you want to name all your columns. Insert into student work, or insert into student name, email, so you do it that way. But there are some times where there are some, I won't even say times, I'll say in some methodologies where, you have this kind of system where, that's how it makes sense to do it. So this is one of those things where you really want to be careful because if you add a column if you have a natural join and you add a column that has the same name as something else, you may end up really messing up your natural join. Because you're giving, you have a name column in one and there wasn't a name column in the other, but then you decided, you needed to add a description, so you added the name. and then all of a sudden half your application doesn't work because you were using a natural join. Now, much like the using clause, a natural join is a way to type less, right? You don't have to say, in the using clause, you can say using student ID as opposed to on student work dot student ID equals student dot student ID, right? If you just did a natural join, right? I could do a natural join of, let's see, select name, grade num from student, natural join student work. Oops. And now I've got, 48 different rows of a natural join because it just naturally joined it on student ID because that was the only field name that those two have in common. And even if the foreign key wasn't there, it would still do that natural join. Natural join has nothing to do with foreign keys. Now the problem is if you're thinking like that, and you think, oh well, it's just going to use the foreign keys, and one is student ID and one is just student.id, those won't actually match up. They have to be the same physical table name, column name. So natural join, I think I did something similar here. Yeah, instead of you using student ID, I just said natural join. It's a lot cleaner. Things like that. I usually don't use natural join because again, that's making an assumption about what columns you have. And again, if you saw this and it wasn't doing the right thing, you wouldn't know what I had when I had written the query, what I had intended to join it on. So I prefer something like inner join student work using student ID. You know that I intended to do an inner join of these two tables, and I intended it to match on that one field. That's really very clear, and if it doesn't work, you still know what I originally intended. Maybe what I originally intended is wrong, and maybe it should be a left join, but at least you get a sense of what I had tried to do.
Is there any design pattern where a natural join would be preferable?
Yeah, I mean, in general, it is preferable as a design pattern. The problem comes if you have something like an agile methodology and changing your tables all the time, and you might add a column there. I mean, certainly a methodology where, there are some methodologies where every column name is prefixed by the table name. So you never have an ID field. It's always student ID, work ID. So here's where you can have a natural join gone awry, having the same field names but the field aren't equal. So here, if you do, I showed you this before, where the example is join student work with grade num letter on grade num. If you do it as a natural join, the grade letter is also the same name and it won't work. And then this is why the field is called work.wname instead of work.name, because if you end up doing, some kind of a natural join, that's not to say that you should, one of your design patterns if you use natural joins is never have the same field name twice, things like that. But I think it's probably better to just not use natural joins than to never have the same field name, because sometimes you just want the field name to be ID or description or something. So subqueries. A subquery is a query within a query, if you didn't already know that. I find it's a more natural way of thinking for procedural thinkers, or for, I don't want to say like, oh, developers always think this way, but, even if you're an object-oriented developer, you're thinking in terms of a method and how to do it. Not just, I'm the queen, just show me this, I'm not going to tell you how to do it, I don't care how you do it, right, just do it. Did your manager ever tell you, I don't care how you do it, just get it done? It's the same thing, and get it done as fast as possible, right? That's what we tell MySQL all the time, or any database really that's using relational and declarative language like SQL. And it's actually optimized that way. That's why you have an optimizer. I guess procedural code has parsers and optimizers too, but it's more compiling than optimizing. But you don't necessarily, you can use things like index hints and whatever to say, I want you to use this to make it faster, but usually you just say, just show me the data. So we're actually going to get to a subquery. I'll show you a subquery here when we're talking about procedural thinking. So how would you get the names and the grades for test 1? Well, let's think. Okay, well, we want to get the names and the grades, so we know we've got select name and grade num. That's the first part of the query. We got that. Nothing else in the select because that's all we want. Okay? So let's start with the join table, right? We want to get names and grades, and we know that the student and the grade are both in student work. So let's start there, right? That's where we find kind of both pieces of information. We have the ID, not the name, but let's start there. So we're going to get the name and the grade number from student work, and then get the name itself. So, there's no name, there's just a student ID. So now we're going to say, okay, now let's get the name. So now, right now, we've got all of the names and grades, right, with an inner join, but only get test 1. So now we're going to say where work ID in, select work ID from work where W name equals test 1. And so what we're saying is, basically, if this were a math problem, we would do the parentheses first. We would say my order of operation in this math problem is parentheses. Select work ID from work where W name equals test 1. And that would come out to be, I think 2 is the answer to that one. Paste. 2. So what we really want is get that, that's going to be 2, and then we end up saying where work ID equals 2. Now unfortunately, actually, before I tell you this, I believe that this is not how MySQL actually does that. But just in case they've updated the optimizer to deal with this kind of a simple case, I'm going to look at it first. So yeah, we have a dependent subquery here. We actually have 3 different tables, as it will. We're going to go through all. We're going to do full table scan of student, which makes sense. We haven't done any filters on student other than using the student ID. So we're going to go through every single student. And then we've got student work, which is the type is ref. That's good. The key length is 1, and we're using this index, which is good. So this is this join on it. So basically, we're going to go through every student, right? And we're going to say, okay, what is that record in student work? And then 3 over here is the dependent subquery. And what this is doing is doing the dependent subquery. It's dependent, so it's doing it for every row in this number 1 and number 2. It's doing this over and over and over. It's doing this select work ID from work where W name equals test on 4 times. Now that's not optimal. So one of the most important things in terms of declarative versus procedural is parentheses are not what you think they are. Parentheses do not mean they're not order of operations. They're not do this first. That's probably one of the biggest areas where it just like you look at it, you're like, well, why wouldn't you do it that way? You get a number, why wouldn't you do it that way? But that's just not, MySQL is not smart enough to know that that's going to come out to be a number. It could come out to be a huge result set because really it comes out to be a result set. We're talking sets, we're talking the Venn diagrams, whatever. It's going to be a set. MySQL doesn't know that that set happens to be 1 column and 1 row, the number 2. So it could be a lot more complicated than that. And it could actually depend on something outside of here, which is why you get dependent subquery. Because MySQL basically, the optimizer just goes, I don't know what's in here, and because I don't know what's in here, it might actually be related to something out here. So we might actually have to parse it once for every row in the outer query, this is called the outer query, this is called the inner query. So it may seem obvious to us, the MySQL optimizer isn't quite there yet. In Oracle or SQL Server, this query is optimized the right way, and they're smart enough to know that. MySQL is not there yet. So we've got that. So what about declarative thinking? So we're going to get the names and grades for test 1. So I have 3 sets of data. My sets. My sets are student, which has the name. That's the information I want to get out of it is the name. The student work has the grades. That's the information I want to get out of. And then the work data set has the name of the assignment. So I need all of these 3 sets. So you almost kind of start with your tables here, but you're still kind of starting the same way. You're still starting like name and grade num, where W name equals test 1, and you're going to need to use all 3 tables. So now how do the tables relate to each other? How do my data sets relate to each other? Well, the student and student work table relate to each other by student ID in a one-to-many relationship. So I want to get the name and grade number from, so I still have name, grade, and then where, but now I'm adding this student inner join student work using student ID. Okay. Now, work and student work relate to each other by work ID. Select grade, name, grade, num from student inner join, so this is what I had before, and now I've added this inner join work using work ID, where W name equals test 1. Now, we got to the same, we're going to get the same result as we got here. So if I actually do this, even though this is not an optimal query, if I run it, I'm not going to get the right answer because I have to apparently copy it into my buffer. Paste. There we go. So I get 4 here, test 1, there's, grades here for test 1. If I do this with the declarative here to here, paste, I get the same 4 rows. You can see 88, 175, 100 is Shiri, Giuseppe, Colin, Ronald, and then 88, 175, 100, Shiri, Giuseppe, Colin, Ronald. It's the same data set. But it's optimized differently. If I do an explain on this, paste. Now I still have the 3 rows, but there's no dependent subquery. Here I have, this is still a full table scan, but it's on work. Notice the work table comes first in this one, not the student table, which is interesting. And it's looking through 14 rows, but it's using where, and it's using the primary key. So it knows that as soon as it gets to that one row, it can stop looking because it's only a primary. It's using the primary key to match on a value. So as soon as it matches on the value, it can stop. So even though it says that it's going to look through 14 rows, that's the maximum it's going to. That's like O of n right there. The maximum it's going to look at is 14 rows. So the next one here, student 2, is student work, and so again, it's going to take that one row it found from work, and it's going to join it to student work. Then it's going to join it to student. And here it's using where, and it's using a join buffer, which is interesting. So it's optimized completely differently, even though it gets you the same answer. They're both correct, but this is going to be a lot faster. And it's hard to tell just by looking at this to say, hey, I know I can optimize that subquery away, I can optimize that into a join. You just kind of have to try to think about it differently and say, is there any way that I could, I'm already, the problem is like you're already kind of, I guess you're not really joining the work table. You're already using the student work table and the student, so you're kind of like, well, this is a completely different table. You know it's not dependent. It's a completely different table, so maybe I can do it as a join. That sometimes helps when they're different tables, but there isn't an easy formula to figure that out. But this falls apart for test 3 because I didn't take test 3. We saw in the example earlier that we did a cross join and whatever, but I was trying not to make it like, oh, if you did it in sets, you would see the cross join, because you wouldn't necessarily. So getting all the grades for test 3, you might start with something like select name, grade, num from where W name is test 3. Okay. And again, thinking in sets and thinking in relations, how does this relate to that? Well, what do we want? What do we want to see? We want to see a listing for each row in work against each row in student. Even if there's nothing in, even if there's no grade for it, we want to see it, right? There might not be a grade, but we want to see Shiri and test 3. We can then relate that to the student work table to see, does Shiri have a grade for test 3 or not? So it's that kind of, it's that kind of thinking where you say, this is what we want to see. I didn't say how to do it, right? I said this is what we want to see. And this is really where the power of declarative thinking will really, it's so hard for me to say, well, how did I just know that I could optimize that subquery away into a join? I didn't know, I just kind of saw the sets of data. I saw how they related to each other. A lot of times when I'm optimizing, one of these 7, 8 join queries, I'll figure out what is it trying to do? What is the result trying to get me? What report are you trying to do? And I'll translate it into this English. What am I getting? I'm getting, number of orders per day per state, right? That's show me this. Anything that's show me this, what do I want to see? as opposed to it's going through this table and then it's going to do that, and then it's going to go to that table and join it against that. That for me loses its meaning very quickly, because I'm just like, okay, I followed the thread from, you know, A to B to C to D, but I don't know why I did that, right? So a lot of times, again, I can say, okay, what is this trying to do? Figure it out. So even just saying this is declarative. It's what we want, not how to get it. So when you're sitting here going, okay, how do these relate to each other, right? We figured out, okay, we're going to start with the name, the grade, and then we want a listing in each row and work against each row and student, whether or not that exists, because grades might not exist for all the rows. So again, the last example or the last time I was going through this in a declarative way, I wasn't even thinking about that caveat, that hey, there might not be a grade for every row. So there, you know, I've now presented two different declarative thinking kind of, you know, paths, right? Somebody might think of it that way, of the first way, and somebody might think of it the second way. They're both declarative ways of thinking, right? One was just plain sets without thinking of how things may or may not really relate to each other other than kind of joining. But this is really kind of getting meta on that level of, well, grades might not exist for all the rows. And that's really, really hard to do. It's not something that, I mean, I don't even see that all the time. It's very, you know, it's one of those things that you play with the data and you're like, what do I expect to get? Did I get that back? Why not? Oh, you know, once, it's more of, you know, sometimes you almost have to hit the bug before you realize you didn't think of that. But I hope that this, do people think that this can, you know, maybe help them a little bit, maybe whether they draw it as a Venn diagram or whatever. It's, you know, again, if there was an easy formula of like, in order to see the, you know, write the best query, do this, there wouldn't be hundreds of courses on how to do it, and you know, there wouldn't be, you know, it wouldn't be so expensive to hire a DBA to optimize your queries for you. So basically, the grades might not exist for all the rows, so we'll need an outer join, right? We've already done the cross join of show me one row per person per work, you know, test, homework, final exam. Now what we want to do is we want to get the grade for that cross join, but the grade might not exist, right? So we're not going to want an inner join, because in an inner join, it's going to show you what exists on both sides. If you have something that doesn't exist, then you know you need an outer join. Now this is another way that it might help you rewrite a subquery as a join. Because a lot of times when you're doing a not exists, you say where this is not in this set. And again, it's another way of thinking of sets, where you say, hey, I've got this set and I've got this set, and I want the subtraction. If you're doing that kind of subtraction, it might actually help to do an outer join. This, you know, it's this exclusive kind of thing where you're only getting one side of it. So for here, now we're saying, okay, we've got this cross join, let's fill in the values from student work for the grades that do exist, joining on student ID and work ID. So we've got this select grade num from student cross join work that we had before, and now from here I want to say, you know, I want to say for every row here, for every row in this thing, and that's why I have a left join. If it was a right join, it would be every row in student work, and that's not what we want. We want more than that. So we could say select grade num from student cross join work, left join using student ID and work ID where W name equals test 3. And this was the query that we showed before, except I think we used a coalesce. Paste. So again, now you get the null because I didn't do a coalesce, but that's what you get the 4 things. One of the interesting things is if you end up, the way that I learned outer joins, or the way that not the way, but the reason I had to learn it, we will have these like defining moments unless you took a course or something, you kind of had to figure out what am I doing wrong here. I was trying to find you know, all days that has sales of greater than $0, you know. So one of the more interesting problems, and this is kind of a longer example, was dropping the lowest test score. Right? This is, you think, okay, well, you know, you just take the lowest test score and you drop it, okay. So I started thinking about it. My first instinct was, let's say for our purposes, null equals 0. So if I didn't hand in an assignment, I got a 0 on that assignment. So that would be the lowest. We'll need to keep that cross join because we need to know whether it was null or not, right? You're not just going to drop my lowest grade for a test because my lowest grade doesn't actually appear in the student work table. My lowest grade is 0 for the one I didn't hand in. But you don't know how many I handed in or not. You have to, maybe I didn't hand in 2, right? So we still need to keep the cross join. We have, select name, grade, num from student, cross join work, left join student work, using student ID and work ID. Okay? Now from there, okay, we can get all the tests, right? So again, you've got this thing where, so all we're doing here is we're adding where W name like test. Okay, now here I say we expect 24 rows returned. Why do I say that? Well, if we're getting all of the tests, then, and we're using the cross join, then what we expect is 6 tests, because there's one for every 6 weeks, test 1, test 2, test 3, test 4, test 5, test 6, times 4 people. So let's see if we get this. And again, we do. Now we can look at it, we can say, okay, look, okay, there was only one test that was never taken. It was null. And that was, the one that I did, test 3. Now, one interesting thing is, if we do it with homework, there was, Colin didn't, enter in any of the homeworks. There should be a lot more null. In fact, there are. And you can see, like, every 4 ones, like this, we can actually order by name. And then we could see that in this section here, Colin didn't hand in any of the homework. I was a slacker on one assignment. So, alrighty, so we're getting there because we're starting to say, okay, we're saying, show me all the test scores. Now we can kind of whittle that down. Now, what about the minimum grade from the test per person? From all the tests per person, right? So show me the minimum grade for each person. Now, we expect 4 rows because we expect, Shiri's lowest was this, and Ronald's lowest was this, and Colin's lowest was this. So I have the same thing as I had before, but now I'm grouping it by student ID. I can also group it by name. There we go. And indeed, what I get here is this. Shiri 88, 85, 70, and 75. But I didn't do test 3, right? So why is it saying 88? It should say 0 or null, right? Why is it doing that? Anyone want to hazard a guess why it's doing that?
Well, you have to do min of coalesce grade num 0, or min of if null grade num 0, whichever you want.
Okay, so I'd have to do min of coalesce grade num 0, like that. Yep. Yep.
So they all have to be null for min to return null. I ran into a problem where if you have like 4 records and they're all null and you do min, you can get null as the return value from the table. But if there are any non-null values, then you get the minimum value, even though the other records have all null.
Right. The minimum of null is null, but the minimum of null or 0 is 0. The minimum of null or 100 is 100.
Right.
Because null isn't even a number. So if MySQL can, it will try to say, okay, minimum means number. Do I have a number? Okay, great, let me find the lowest number. But if it doesn't have any numbers, it's like, I don't know, null. It's like you're giving me the minimum of Q. I don't know.
How do you get rid of null?
How do you get rid of null? You don't.
Oh, okay.
You don't. I mean, you can use coalesce. We got 4 rows, but we didn't get the right ones because we didn't coalesce. But let's say if we have the coalesce here, now is there a way to convert this to an update statement, where we say, update student work, so student work limit 5. We have this 4 grade. So the idea, remember back in the beginning of time, the idea was which grade do we drop? So now we've got this, and we can use the coalesce to get the right one. Well, how do we drop it? How do we update this so that the 4 grade is N? And this this turns out to be really hard because you have the group by here. So so how can we try to do that? Well, let's try, update student work as, let's see if we can, we can't really do it with this, so let's try to see what we can do if it's like a set. Let's see if we can just kind of join this set with another set and then like update that other set. Maybe that's how we can do it. That's kind of where my thinking went to, right? So let's see. So what we want to actually update is student work. So the next set is going to be student work that we're going to add. So what I did was I did update student work as UPD. So there's going to be 2 student work tables. We're going to have the regular stuff that we had before. And so basically what I did, this was backwards. So instead of work, cross join, student, I have, and then doing like a left join, I ended up doing basically update student, inner join student work. So it's the same student work, inner join student work. It's self join using the student ID and work ID. So the idea is somehow this will get the student ID and the work ID of the minimum, and then I'll use that with this join to update this. So I have this, again, right join instead of left join, and still have the cross join of work. Set update for grade equals N, where W name like test, and update grade num equals min of the select grade num, group by the select of student ID. Because the problem was the student ID group by, so we're not updating that group by, we're updating the thing that we joined it to. So now this should work. Now the reason this doesn't work is actually that it doesn't let you do, it doesn't like the group by. It doesn't like what's right before the group by, which is this, where update grade num equals min of select grade num. That's what it doesn't like. Okay? Let's try a subquery. Alright, so let's update student work, set 4 grade equals to N where. Okay, got that so far, that's pretty easy. Where, let's see, let's do an in statement. So where this pair of student ID and work ID, because really this is your primary key, right? A student's not going to see the same test twice. We didn't actually put that in as a primary key, but there's the natural order of things is, you know, the student doesn't take the same test or doesn't submit the same homework twice. So we're going to say where this pair, so I'm concatenating them because the in statement can only take one value, you can't take 2 values. So it's in, select this. So now if I do this select statement should work to get me what I want, unless I can't copy and paste it properly. But it's select concat student ID work ID from student, cross join work, left join student, where W name like test, group by student ID. This is exactly how we got the coalesce of the minimum grade. And basically what we get here is we get the concat as 1, 2, 2, 2, 3, 2, 4, 2. That's what we get. We group by student ID. It's concat, the student ID is 1 and the work ID is 2. Okay, so let's see if this will do what we want it to. Because it should do what we want it to. But it doesn't, because you can't actually, it says you can't specify target table student work for update in from clause. Because it's a target, so you can't also update it. It knows that we've actually used, we're trying to update student work, but we've also put it in this select statement. And it's like, you can't do that. Okay? So now what? We can't use a subquery, we can't use a join.
Is that true in every case, or are there...
No, it's not true. It's not true.
Because I was just reading about that and update, and there's...
This is a dependent subquery.
Oh, it's a... But it can be a table.
You can
If
have
it's
a
not
derived table. You can have it like in the from clause. So
Right, but
I
you
just
can't
kind
have
of
the
wanted to
subquery,
show
that's
you
what
that
it was.
sometimes you're like, okay, well let me just try to use the bad way of a subquery. And that doesn't even work. You can use a derived table, which is basically usually a subquery in the from clause, where you basically make this temporary intermediate table. But, you know, the same idea, you can actually make a temporary intermediate table by having a temporary table. So sometimes you need to do it in more than one query. That's just the moral. Sometimes that just needs to be the way it's done. Sometimes you don't need to do it in more than one query, but it's actually optimal that way. A lot of times people are like, yeah, no, I can write this in one query, and they got like 70 table joins, and I'm like, well, you could just do it in like 2 queries, and it would be a lot faster.
And a lot
like,
easier to debug too.
yes, but then they're like, but then it's two different queries, and isn't it going to definitely be faster if it's one query? Because, you know, in general, is one query probably faster than 2? Sure, if you're talking about the same exact query, you know what I mean? If you're talking about doing complex stuff. And the problem is the group by and the minimum of the grade number, and the minimum coalesce grade num. So let's use a temporary table. We have a temporary table of the grade to drop where basically we're going to put this minimum table in, right? This minimum grade number with the student ID. There, so now we have 4 records in there. But this doesn't work because I only put the grade in there, not the student ID as well. So let's see what I did here. I actually made student ID, work ID, and as it turns out, you can't just have the student ID because what if you have 2 zeros or 2 of the lowest grade? You don't just want to delete both of them. You only want to delete one of them. So as it turns out, you need the student ID, the work ID, and the grade number. Drop table, grade to drop. Oops. Paste, boom. So select star from grade to drop, nothing yet. So then we insert into grade to drop the student ID and the grade number. So basically we put both in there and we say, okay, now select star from grade to drop. Has in fact the lowest grade for student ID 1, 2, 3, and 4. But it doesn't have the work ID. It doesn't have which assignment it was. It just knows that Shiri's lowest test grade was a 0. And really, it doesn't matter which 0 it is. We just need to delete one of them. So then what we can do is we can join now this grade to drop table with student work, setting the work ID. Now it's only going to, it's only going to set 1. So it doesn't need to set anything more than that. So we do that. 3 rows affected. Okay, why not 4 rows affected? Well, because this grade num was 0 and it joined with null. So you'd have to figure something out for that. I actually tried, in my test, I actually tried putting, let's see, set work ID equals work ID. Oh, where I did this was with coalesce grade num comma 0, but that actually didn't work either. You could do something as simple as before you start set null equal to 0 on the work ID or whatever.
But why is not the null value correct? Because you actually don't have a record that you want to drop.
Exactly, and that's what I realized after that. So his thing was that why is it incorrect? Because you don't actually have a record to drop. You don't have something to update, and that's exactly it. Because when you update to set SW4 grade equals n, we're just updating it to say join on student ID and work ID, which is what we were trying to do in so many other ways. So now if we do that, paste. Now if we do select star from student work where 4 grade equals n, we don't get anything for ID of 1. And we actually got 2 for person 2, but I think that was like that before because I've been playing with this and actually work ID 6, 10, 12, 13. Yeah, work ID 6 and 10 are not, like one of those is homework. Not test. 6 is test 3, 10 is homework 5. So this is from when I did it before because the next step is to repeat for dropping the lowest homework, and then you can drop the temporary table. And then, from there you can actually go on to calculating the grades. The idea was to kind of go on to actually calculating that, what's their final grade. But I realized that from here it's just math. There's not really there's some joining of the tables, but it's just like, okay, add these all up and take a percentage, and then it's more playing with group by than with anything else. So basically, more best practices. We talked about some about how to actually physically write the queries. We talked about some of the ways to optimize and some of the ways to think to try to say, okay, how can I optimize the subquery into that? When in doubt, what I usually do is I write down what I want to get out of it. And when you're doing that, you can see I'm actually giving it like the procedure. I'm like, start with this and then go to that. So when you write it down, try to write down what you want to see. And if you think of it as a report, right? If you think of it as, what do I want to display on the page? I want to see this column, this column, this column, and what's the meaning of what I see. It's that stuff for all orders over $100,000. It's this stuff for the month of January. And then try to write the query again. If that doesn't work, give your coworker your description. You say, I'm trying to write a query that does this. Can you help me? And they will come up with the most brilliant way to do it because they haven't been staring bug-eyed at their first example, for a long time. Sometimes it's not even possible to optimize it. It's not possible always to optimize a subquery into a join. It's just sometimes it's not possible. Explain all of your queries and try to get the best type possible. Again, easier said than done. You could say, okay, well, it's doing a full table scan, that's bad. Maybe it's the only way. Sometimes it is. Avoid join hints. We didn't really talk about join hints, but you can actually say prefer this index a little bit. You could say force the use of this index. You can also use straight join, which is kind of listed as a join type, because instead of saying, A inner join B or A left join B, you say A straight join, which is actually an inner join, but the optimizer will take the order as that's the order. So if you say, join A, B, and C, if you say A inner join B inner join C, it might actually do the join in any order, depending on what other filters are there and what it can, optimize out. And if C ends up having 4 rows in it and A has 100 rows in it, it's probably going to do C first, just because there's less to have to try to join. If you did A straight join B straight join C, it would go to A, get the 100 rows, go to B, get 20 rows, and then go to C and get 4 rows. So it's basically like an optimizer hint. It's basically saying, do it this way. The benefit of optimizer hints is that sometimes the MySQL optimizer is wrong. The drawback to optimizer hints is that when whatever calculation happens, or however much data is put in or taken out, where the MySQL optimizer is right again, you're going to have a problem because you've said, don't do what you're thinking, trust me, I know better. And usually you don't. Sometimes you do. So try to avoid them if you can. So try to optimize subqueries into joins if possible. We talked a little bit about that. Unfortunately, there's no hard and fast rule of when you can do it, when you can't do it. And that's it. Any questions, comments? Any flaming pitchforks that you want to throw at me because it's like 9:30 at night, and that was hopefully good and not too much information. Thank you.